Imagine, if you will, a moment that defies our everyday understanding of life. It's a moment we all contemplate, but few truly comprehend. A moment not of speculation or belief, but of stark biological reality. The moment a doctor, looking at a flat line on a monitor, pronounces a time of death. But what if that pronouncement isn't the end of the story? What if it's the beginning of a strange, transitional chapter? Today, we're not going to explore the supernatural. Instead, we'll peel back the curtain on the first critical minutes after the heart stops, relying solely on what science and medicine have observed in the strange place between life and finality. The cascade of events begins with an abrupt silence. The rhythmic thump that has accompanied every second of your existence ceases. Your heart stops beating. In an instant, the intricate pump that circulated life-sustaining blood throughout your body grinds to a halt. The consequences are immediate and dramatic. Within a mere 3 to 5 seconds, your blood pressure plummets to zero. The flow of oxygenated blood to the brain, your body's command center, is cut off. From a clinical perspective, this is the demarcation point, the moment defined as clinical death. The machine has stopped, but the processes inside the ghost and the machine are far from finished. In the seconds that follow this cardiac arrest, something astonishing occurs within the brain. For a long time, it was assumed that brain activity would simply fade away, like a light bulb being slowly dimmed. But recent studies, including groundbreaking research published in 2023 and 2024, have revealed a starkly different picture. In the final moments of a dying brain, there is a massive final surge of neural activity. Specifically, scientists have recorded a powerful burst of gamma waves, the same type of high-frequency brain waves associated with heightened consciousness, memory recall, and lucid dreaming. It's a paradoxical storm of electricity in a brain starved of its most vital resource. This isn't a supernatural event, it's a physiological one. Some researchers theorize this could be the brain's final, desperate attempt to make sense of the shutdown, a neurological fireworks display before the darkness. It's a process that lasts for about 20 seconds, a brief, intense flare of cognition at the very edge of oblivion. As this internal electrical storm subsides, the outward signs of cessation become more apparent. Between 20 and 60 seconds after the heart stops, the eyes, often called the windows to the soul, undergo a distinct change. The pupils, which constantly react to light and emotion, become fixed and fully dilated. The intricate muscular control that governs their movement is lost. They no longer constrict in the presence of bright light or widen in the dark. They are frozen, open, and unresponsive. This is one of the classic signs a physician looks for to confirm that the brain is no longer responding to external stimuli. It's a silent, powerful indicator that the connection between the brain and the body's sensory apparatus has been severed. The cascade of shutdown continues downward through the body. Over the next 1 to 3 minutes, all reflexes disappear. The knee-jerk response a doctor tests with a small hammer. The blink reflex when something approaches the eye, the gag reflex in the back of the throat, all of them vanish. The body's nervous system has ceased its automatic communications. At the same time, a profound relaxation sweeps through every muscle in the body. This is not the gentle relaxation of sleep, but a complete loss of tension, a state known as primary flexidity. This total muscular release can sometimes lead to the emptying of the bladder or bowels, a final, humbling return to the most basic biological state. The body, no longer held together by the constant hum of muscular activity, simply lets go. From 3 to 6 minutes onward, the visual changes become more pronounced. Without a heart to pump it, the blood, which carries the reddish-pink hue of life to our skin, succumbs to the simple, undeniable pull of gravity. The skin begins to turn pale, a waxy ashen color, as the blood drains from the capillaries near the surface. Simultaneously, it starts to pool in the lowest parts of the body. If the person is lying on their back, the blood will settle along the spine, the buttocks, and the backs of the legs, creating a purplish-red discoloration. This phenomenon, known to forensic scientists as rigor mortis, or the bruising of death, is one of an ME's first clues in determining the time and position of death. It is the beginning of the body's deconstruction, a process governed not by biology but by physics. Concurrently, another physical process is underway. The human body is a furnace, constantly generating heat to maintain its core temperature of around 98.6 degrees Fahrenheit, or 37 degrees Celsius. When the heart stops, that furnace is extinguished. The body begins to cool, losing its internal heat to the surrounding environment. This process, known as rigor mortis, is a slow and steady decline. On average, the body temperature drops by about 1.5 degrees Fahrenheit, or 0.8 degrees Celsius, every hour. The rate can be affected by ambient temperature, clothing, and body fat, but the trajectory is always the same. a gradual return to the temperature of its surroundings. Within the first 10 minutes, this change is not yet dramatic, but the cooling has begun. The warmth of life is slowly, irrevocably seeping away. Around the 8 to 12 minute mark, the initial relaxation of the muscles gives way to its opposite. The first subtle signs of rigor mortis, the stiffness of death, begin to appear. This process is chemical. The body's cells, deprived of oxygen, can no longer produce the energy molecule, ATP, which is required for muscles to relax. As a result, the muscle fibers lock into place. This stiffness doesn't happen all at once. It follows a predictable pattern, typically starting in the smallest muscles first. The eyelids, the jaw, and the small muscles of the neck are the first to stiffen. This is why a deceased person's eyes may seem partially closed, or their jaw may feel tight. It's a progressive stiffening that will eventually spread to the rest of the body over the next several hours, a grim testament to the cellular energy crisis unfolding within. This brings us to a critical and perhaps the most important threshold. Between 10 and 15 minutes after the heart has stopped, the brain cells, starved of oxygen and glucose for this long, begin to suffer irreversible damage. Without oxygen, the delicate cellular machinery that supports thought, memory, and consciousness breaks down. The cells swell, their membranes rupture, and they begin to die. For decades, this 10-minute mark was considered a point of no return. Once this process of cell death began, it was believed to be absolute. And yet this is where the story takes another strange turn. Science is constantly pushing the boundaries of what we consider final. Researchers like Dr. Sam Parnia and the AWARE-2 study have documented incredible cases of people being successfully resuscitated well after this 10-minute window has passed, sometimes after 20, 40, or even 60 minutes of cardiac arrest with no discernible neurological damage. How is this possible? The answer lies in the heroic efforts of doctors and nurses in the emergency room. When a patient is in cardiac arrest, the medical team is not just standing by. They are in a race against this very timeline. They perform high-quality CPR, manually forcing blood and oxygen to the brain. They might use therapeutic hypothermia, rapidly cooling the body to slow down the brain's metabolic rate. This cooling process acts like a brake, dramatically reducing the brain cells' need for oxygen and preserving them long enough for the heart to be restarted. They are, in essence, buying time, extending that critical window, and challenging our very definition of irreversible death. This brings us to one of the most profound and puzzling aspects of this entire experience. Some patients who are revived from this state of clinical death, even after their brain has shown no signs of activity, report having vivid, lucid, and structured experiences. These are not the vague dreams of an unconscious state. As documented by researchers like Dr. Bruce Grayson and in studies like the Lancet-published AWARE reports, these individuals sometimes recall seeing and hearing the doctors and nurses working on them, occasionally describing events they could not have possibly known. Others report a deep sense of peace, a journey through a dark space toward a brilliant light, or a review of their entire lives. For years, these were dismissed as hallucinations caused by a dying brain. But the fact that they can occur during a time of documented flatline brain activity, and that the gamma wave surge is now a recorded phenomenon, forces a more serious scientific inquiry. These experiences are not proof of an afterlife, but they are evidence of a level of consciousness at the threshold of death that we are only just beginning to understand. So the next time you hear a doctor pronounce a time of death, remember that it's not an instantaneous event like flipping a switch. It is a process, a complex and fascinating biological cascade that unfolds over minutes and hours. It is a frontier that medicine is still actively exploring, pushing the boundaries of what it means to be alive and what it means to be gone. The story of what happens in those first few minutes is not a tale of horror or the supernatural. It is a story of biology, of physics, and of the enduring mystery of human consciousness, a mystery that continues, even when the heart falls silent.